Hello and welcome to another Ginger Mathematician video. Different style video today. I'm going to be doing a 30-minute cram session on all things polynomial functions for grade 10 mathematics in Germany, particularly in Bavaria. This is also known as Ganzrationale Funktionen. I'm going to do 30 minutes of exactly what you need to know to do really well in your Schulaufgabe and your test generally. So I've got my timer here. So I'm going to time here for 30 minutes. And we're going to start now. So first of all, let's start with functions that we actually know. So if we want to sketch y equals 5 here, again, if we do a quick graph here for y equals 5, key thing to realize is we start with our y-intercept of 5, but notice if I did a point here as well, so this would be the coordinate 1, 5, or if I did a coordinate over here, this would be then at minus 2, 5. Okay, what do all these things have in common? Well, they all have 5 as the y coordinate, and this actually makes a horizontal line here. So y equals 5 is just a horizontal line, but you do need to know that basic function. Then we go on to straight lines in general. So y equals 3x plus 1. This 3 here, this stands for the gradient, and important later on, this number after the x's and x squareds and x cubes, that's going to give us our y-intercept. So if I was to draw a quick sketch of this, again, I draw out my axes, very, very important, particularly in the German system, knowing how to draw these functions. We start at 1, and if we want a gradient of 3, that's going to be 1 along and 3 upwards, giving us a gradient triangle, or Steigungsdreieck in German, and then we join these things together, giving us a pretty steep line here, like so. And we're also going to look at later on how we work out the x-intercept, the root, or the Nullstelle as well. Then you probably moved on to things like this. Now, because we have an x squared, this is known as a quadratic, which is a really important thing to know. And if we were to sketch this, again, we have a kind of three-step procedure here. First of all, the y-intercept, like I mentioned with the previous function, is just the number, so that's equal to minus 6. The second thing, we want to work out the roots, the Nullstellen. In order to work that out, we take our quadratic and make that equal to 0. At this point, you can solve this in lots of different ways. I'm sure lots of teachers have talked to you about the so-called Mitternachtsformel, or the midnight formula, the quadratic formula, which is very recognizable, and you can work out where it crosses the x-axis. You can also do this through factorizing, which we talk about later in this video. Okay, I put x at the start. What two things multiply to give me minus 6, but add to give me minus 1 here? And so we have minus 3 and plus 2. Then we use the null law, or the 0 law, which says basically that this times this is 0. So that means either the first bracket is 0 or the second bracket is 0. And then that gives us x equals 3 or x equals minus 2. This tells us where it crosses the x-axis. The third thing we should consider is, because we've got a positive quadratic, we talk about this later in the video, is it a happy face or a sad face? Because it's a plus x squared here, we are going to have a happy face. And what we can do is combine this all together to give us a drawing of our quadratic. So it goes through minus 6 here. We've got our x-intercepts, a Nullstelle of x equals 3 and negative 2. And because we know it's a happy face, we start here, we go through here. Our minimum point is a little bit after the minus 6, which we work out more in elfte Klasse later on. And then we get our lovely quadratic looking like this. Again, you can get different kinds of quadratics. This is one certain kind here with the number missing. Same procedure. So we have y-intercept is equal to 0 because there is no number here, and then we use the same method. We want to work out where it crosses the x-axis, and we can actually factorize into a single bracket here. So we have x bracket minus x plus 8 is equal to 0. That means either x is 0, so this bit is 0, or the bracket is 0, minus x plus 8 is 0, therefore x is equal to 8. And then, do we have a happy face or a sad face? Well, because we've got a negative quadratic, we're going to have a sad face. And again, we can sketch this quite nicely using all the information so far in the question, going through at 0, going through at 8, and we have a sad face, so we get a graph looking something like this. In fact, we could actually work out the x point of the maximum point here because it's always halfway between 0 and 8. So we actually know this will be at 4. Again, we can also use the acts as a symmetry formula to work out the same thing. Now, when we move on to more difficult polynomials, non-familiar functions, as I've said here, notice here we've now got a cubic because we have x to the power of 3. So we generally call this a cubic. And I've drawn this in GeoGebra to give you an idea of what the function looks like. So on the left-hand side and right-hand side, does it go upwards or downwards? Now, what do I mean by this? Well, we have left and right. If I look at the left side, notice if I kept following this, it's going down and down and down and down. Now, in German, you call this links unten. So at the left-hand side, it's going downwards. Again, we can say this is going down to negative infinity. We can use a different expression there. And here we have it's going on the right, it's going upwards. So in German, we'd say rechts oben. And again, all we're saying here is as we go to the right-hand side, it's going to plus infinity. Now, the next thing is, does it bend in the middle or look like a quadratic? Remember, a quadratic always has this happy or sad face. Notice this function here has this kind of bend here in the middle. So it bends and then goes upwards. So it does have a bend, this x cubed function. And if I change any coefficient to a negative, what happens? And we're going to investigate this particular question in the next slide. So I've got some random functions here, and we just need to answer the same questions that we looked at here. So if we take this first function, let's go over to GeoGebra and look at this. So GeoGebra is a really useful tool because you can investigate lots of different functions and get a feeling for what's going on. So here we're going to do x to the power of 5 minus x to the power of 4 plus 2. And we pop that in. And if we get the function here, notice it has the same property that we looked at with x cubed, which was links unten. So at the left, it's going to negative infinity, rechts oben. On the right-hand side, it's going to plus infinity. And we have this bend in the middle as well. So actually, this first function that we have here actually works in a very similar way to this function. So we have this left minus infinity, right plus infinity, and we have a bend. That's important to realize. Whereas if we actually change this to a negative, so negative x to the power of 5, so let's go back here and just change this to a negative, notice what happens. So we put negative in the right place, of course. There we are. Notice it's just flipped essentially, reflected. So now at the top, it's actually going, oh, I don't want to move it too much. There we are. So on the left-hand side, it's actually going upwards, so to plus infinity. And on the right-hand side, it's going to negative infinity. So one thing we notice here by exploring these functions in GeoGebra is for this one, we get the opposite process. For left, it's going to plus infinity, it's going upwards, links oben. And then on the right, we're going to negative infinity, so rechts unten. So this minus here does change quite a lot. However, if we go back to this function and change a different sign, say I change the x to the power of 4 sign to a plus, notice there's not much difference at all in the graph. So the highest power is what we really focus on to see the general shape of the graph. Now we can investigate other kind of functions as well. So let's look at question 2 here. So x to the power of 4 minus x to the power of 3 plus 1. So if we change this in, so we've now got x to the power of 4 and then minus x to the power of 3. If we expand this out so we can see and change this to a plus 1, notice this function works very differently. So here we've actually got something very similar to our happy face quadratic that we saw before. So links on the left hand side is going upwards plus infinity, and on the right hand side it's also going to infinity as well. So if I write this in for this function, we have left is plus infinity. I'll summarize all these rules for you as well. And right is also plus infinity. and it looks like a quadratic, a kind of strange quadratic in the middle. So by investigating this, we can actually see some of the links between the highest power that we have in our function and the shape of the graph. And in fact, I've summarized this for you on one of the following slides. So if I skip forward here, if we've got x to the power of 5, x to the power of 3, we have some kind of bend. This would also be x to the power of 7. So all odd powers have this kind of bending effect. If they have an even power as the highest power, then we have some kind of quadratic shape. Notice this number at the end is still the y-intercept. That hasn't changed from what we did right at the start. And notice if I take these functions, x to the power of 7, x to the power of 6, you can see as soon as you put a negative in front, it reflects it essentially in the y-axis. So we change that property of left upwards, right downwards, or the other way round. So this list is really, really important so you can understand exactly how these polynomial functions work. Now, if I want to talk about the behavior of a random function as it goes to infinity, so let's do an example together here. Notice it's in a kind of factorized form. So the way to find the behavior is to actually expand our brackets first. So remember our FOIL method for expanding, first outside, inside, last. So this times this, this times this, this times this, this times this. If I do this quickly, we get then minus 2x cubed, outside term, so plus 2x, inside term plus x to the power of 5. Careful, negative times negative is a positive, and then we have negative x cubed. So if we collect this together, we get x to the power of 5 minus 3x cubed plus 2x. So the behavior of the function, if we use our rules on this slide here, we have a positive, so it has some kind of bend. So the function is going to look something like this kind of idea, because we have an odd power here, x to the power of 5. So here on the left, it goes to negative infinity, and on the right, it goes here to plus infinity. We only care for a polynomial about the highest degree of that polynomial, the highest number. That is what actually affects the shape of the graph. Now, even though with some functions it can be quite hard to find the point where it crosses the x-axis, we can use quadratics to help us. So here, for example, this is a quartic, and we want to find where it crosses the x-axis. Notice we haven't actually been taught how to do this, but you can use for what's known as a biquadratic equation. That's the official name for this. We can actually solve this like a quadratic. And the way we do this is a substitution. So I let y equal to x squared. So this middle term here, the reason I've done that is if we square both sides, y squared is just y squared, x squared all squared, well, 2 times 2 here is equal to 4. Now the reason we've done this is wherever I see a x to the power of 4, I can put a y squared. Wherever I see an x squared, I can put a y. So then this leads to 5y squared minus 24y minus 5 equal to 0. And then we can use our normal quadratic solving abilities in order to work this out. Now I generally like to factorize when possible. Makes your life a lot easier. And with a little bit of thought, we can actually work out these brackets. The quadratic formula is absolutely fine here. So that means either then y minus 5 is 0, therefore y is 5, or 5y plus 1 is 0, therefore y is equal to minus 0.2, or minus 1 over 5. However, we're not finished with this question because we need to back substitute. Remember, y is equal to x squared. That means then that x squared is equal to 5, or x squared is equal to minus 1 over 5. Now, if x squared is 5, x must then be equal to plus and minus root 5, square rooting both sides. Notice if we try and do the same here, and do the square root of minus 1 over 5, that won't work in the real number system. So we actually only have two answers here. X is plus root 5 and x is minus root 5. So we have two answers to this biquadratic equation. This is going to be a useful tool for us a little bit later on to work out where the quartic, in this case, or x to the power of 6, crosses that x-axis. It's going to be very important. If you want more practice, you can have a go at these yellow questions over here. These can be very helpful building up those skills. Okay, so we can do that kind of equation by quadratic. Remember, with straight lines, whenever we want to solve, again, we use that commando strich, the opposite of -4, +4. So we add 4 on both sides. That cancels. 7x is equal to 0 plus 4 is 4. And then we divide by 7, giving us x is equal to 4 over 7. The reason we do this, if I actually take this straight line equation, and we looked at this right at the start, so we had -4 as our y-intercept, gradient of 7. All this is saying is this 4 over 7, this fraction, is just saying where we're crossing the x-axis. Another tool, a tool in your toolkit to work with polynomial functions. Take a quadratic here, for example. Again, we can do this in lots of different ways, and we've seen that in the previous part. If we wanted to use the Mitternach's formula, then minus b, 4 plus minus the square root of -4 all squared minus 4 times 1. Too many minuses. Try and do this as quickly as possible. 4 times 1 times -4 all over 2a, so 2. And then we could simplify this down to 2 plus minus. We'll go through this very quickly. You should get lots of practice on this. Plus 16 over 2. And then that gives us our two answers. Again, you can simplify that square root. But we need to be familiar with using the quadratic formula to get those two answers. Mostly stuff from grade 9 mathematics. Okay, now if you want more detail on that, I put more detail in here so you can look it through. There is also completing the square, which you often also do at grade 9 mathematics. So I'll leave those notes there for you. Notice with other quadratics, you have to be slightly careful here. So this one, for example, we can take a factor of 3.5x out again and then solve it in the same way that we've done before. If we get a situation where we have just an x squared and a number is equal to 0, we solve it in the normal way. So commando strich, add 3 on both sides, divide by 5 and square root. Again, I'll put that information there for you. So here, added 3, here, divide by 5, and then here we square root. Now for higher powers of polynomials, so we've looked at lots of things in last year with x squared and x, we can still use some of those techniques. So here, for example, we can use exactly the same technique when we have x to the power of 5 on its own and then just a number. So all we need to do here is just add 1 to both sides, then we divide by 32, and then we find the fifth root of 1 over 32. Now notice, because we have an odd root, we only get one answer here. So that's going to be, or at least in the real number system, and that again gives us 1 over 2. You can check this on your calculator. Again, this kind of equation, we treat it essentially like a quadratic here. What do they have in common? I have an x squared in common. Then we can go 7x squared minus 3 is equal to 0, and therefore x squared is 0. So x is 0. Or 7x squared minus 3 is 0, and we can solve in the same way that we've seen before. Again, I'll leave the notes there for you if you want to go through that in more detail. Now notice this actually here, when we've got 3 brackets, this would actually, if we expanded everything out here, be a cubic. Now I'm sure you're going to say to me, we've never been taught how to solve a cubic, but in certain forms we can use the same techniques. Notice we've got 3 brackets, and they all multiply to give me 0. That means either first bracket is 0, so x is 2, or second bracket is 0, x is minus 3, or third bracket is 0, x is 1. And when it's in a very special form like this, you can actually solve and work out where this cubic, in this case, actually crosses the x-axis. Okay, now once you've got that idea, we can actually investigate this in more detail and use these ideas. So I'm going to try and bring everything together here. Now we've got this idea of a repeated root. What do I mean by that? Well, if we do the normal solving here, so 2 brackets x minus 1, x minus 3 is equal to 0, so x squared is equal to 0. Either x minus 1 is 0, so x is 1, so normal, or x minus 3 all squared is equal to 0. Now remember, squaring something is timesing by itself. So we have x minus 3 times x minus 3 is equal to 0. So either x is 3 or x is 3. You're probably thinking, well, x is 3, that's it. However, with a repeated root, it has a very special property, which is, if this is the root here, and we are coming down from above, it's just going to touch that root and then go upwards. So repeated roots are really important to notice because it tells you it's not just going to cross the x-axis, it's just going to touch the x-axis and then go back in its original direction. So that's something to be aware of. Now, once we've got all that information together, we can then actually start sketching these functions pretty accurately. So let's look at this question here. What would this function look like? We've only got 10 minutes left here. So first of all, if I was to multiply out all this bracket, I'm not going to do the entire thing. That means we get x to the power of 4. So the first thing to notice here is we're going to get an x to the power of 4 function. And it's going to be positive, so that's important to realize. So what will this function actually look like? Well, it will look like a quadratic because we have an even power of x here. So it will look like a quadratic, and because it's positive, we're going to get this kind of shape. So this is kind of what we're looking for here, this kind of shape, which means we're going to have this links orben idea, or on the left-hand side going to plus infinity, and rechts oben, so on the right-hand side, we're also going to go to plus infinity as well. So that's important to realize. Now, if we expanded this entire bracket out, notice the number term at the end, so doing this last part, minus 4 times minus 1, that will give us plus 4. We then multiply that number by the 0.5. So if we do 0.5 times 4, that's going to equal 2. And that gives us our y-intercept. Remember, the number left over with all the x squared and x cubes and things like that, that's going to give us our y-intercept. So already we've actually built up quite a lot of knowledge about this particular function. Our third part here is to work out the x-intercept, the root, the Nullstellen. And the way we do this, and we've done this in previous questions, is we take the brackets and make them equal to 0. So either x squared minus 4 is equal to 0, therefore x squared is 4, so x is plus and minus 2, or x squared minus 1 is equal to 0, x squared is equal to 1, x is equal to plus and minus 1. So what this has told us is x is equal to minus 2, minus 1, 1 and 2. These are all the places where the function crosses the x-axis. Now notice we've built up our picture of the function, and just like with the quadratic we did earlier in the video, we've now got all the information to do a pretty good sketch of this function. So this is the function itself. Let me create a new slide using what we've done so far, and let's see if we can actually get to what GeoGebra says. And this is the key skill that you need. We could give you any kind of function and you need to be able to do a pretty good sketch. So let's draw a nice big set of axes, plenty of room so we can investigate this. First thing, we're going to write down these x-intercepts, these Nullstellen. So minus 2, minus 1. We've got 1 and 2. Again, not the best to scale, but I'll do my best here. We've got a y-intercept of 2, so let's pop that down. So we've got 2 here, and we want the shape to kind of look like a quadratic. So we've got this links orben, rechts orben idea here as well. So if we put everything together, we're going to start from up here. Now we've got no repeated roots, so we're going to cross the axis. Then we're going to come back to the y-intercept, and then back down again. Again, we're not going to just touch, we're going to go through because there's no repeated roots. And then finally, we draw the function going up like this. So by using those 3 facts we know about this particular polynomial, we've managed to draw a pretty good sketch of that function. So if we look at the actual function in itself, Notice we could have gone a little bit deeper in our function, but we're crossing at -2, -1, 1 and 2. We've got going up here, we've got going up here, and we're going through at 2. So I think we've done a pretty good sketch of our particular function that we were given. So just to wrap up everything that we need to know polynomial function wise, and then you can have a go at a question by yourself. Remember, to work out the y-intercept, you set x is 0. That is usually the number at the end. So I'll pop that in as well. If you want to work out what's called the Nullstellen, the x-intercepts, you set the whole function to 0. What you should be watching out for, does it have a bend in the middle or look like a quadratic? Then that depends on the odd power or even power. If we have what's known as the Doppelter Nullstelle, so repeated root, so something like x minus 2 all squared, then you'll have something that looks like this, where it just touches and then off it goes. And then remember, if you've got a negative or positive, we're going to have that reflection effect in the y-axis, which is going to make the function go to infinity in different directions. Now, one thing we need to also look at here is even functions and odd functions. So even function, this is when f of x is equal to f of minus x. I'll do some examples of this in the next 4 minutes. Essentially, we have symmetry here in the y-axis, so called achsensymmetrisch. Here, odd functions, so f of x is equal to minus f of x. And that means we've got so-called point symmetry, punktsymmetrisch, around the origin, around this Ursprungpunkt here as well. I've given you some example of functions where this is the case. Again, you can check this out by looking at the symmetry behavior of the function. The easiest way of doing this is just going f of minus x, so replacing any x with a minus x and see what function you get out of it. So wherever I see an x, I'm going to put a minus x. That's all I'm doing in this particular step, and then simplify. So here we have minus x to the power of 4, so times it by itself 4 times. That's going to give us a positive x to the power of 4. Here likewise, we get a positive here, so minus 7x squared, and then plus 1. So notice this function is exactly the same as the function that we had before. If that's the case, then we have a so-called even function. And if we have an even function, then it's symmetrical on the y-axis. Okay, if we try the same thing here, so we've got g of x, so g of minus x, so that gives us minus x to the power of 5, plus minus x all squared, minus 4 brackets minus x, so that gives us minus x to the power of 5. We have a plus x squared and have a plus 4x. Notice this does not look the same as this function at the start, and it's also, all the signs haven't been switched. Remember, this one here hasn't been switched, so this function is not odd or even, and that means there's no obvious symmetry property here. Okay, I know I've got 2 minutes to go, so let's see how we can go here. Here, if you multiply this out, we get x power of 5 minus 2x cubed. Again, do the same idea here and put minus in. We get minus x to the power of 5 plus 2x cubed. So all the signs are switched, so we get minus h of x. That means it's an odd function. And if it's an odd function, then it has that point symmetry around the origin. Again, we've got a little trick that we can use here. If you have all odd powers, then you can have point symmetry. If you have all even powers, then you have axis symmetry instead. Right, so if I wanted to sketch this function, how could I do this? So first of all, we have no number. So y-intercept is equal to 0. So that's important to know. Then we want to find the roots, so the Nullstelle x-intercepts. So we make it equal to 0. And we can take a factor of x squared out here. X squared minus 1. So either x is 0, and that's repeated, because we have x squared is 0, so that's repeated. And we have x squared minus 1 is 0. So x squared is equal to 1, so x is plus and minus 1. And because we've got an even function, we've got the axis symmetry, and we've got x to the power of 4, so it's going to look like a quadratic. And it's going to be in this shape, a happy face, because we have a plus x to the power of 4. Can we combine everything together in 1 minute to go? Right, let's see what we can do. So we've got y-intercept is 0, it's going through at plus and minus 1, so here's minus 1, here's plus 1. Repeated roots, it's just going to touch, and it's going to come from above. So we're going to get something that looks like this, and just touch, and then come back down again and then go back upwards. So we get this kind of W shape for the win. Let's see if GeoGebra agrees with us. So if we pop this in, x power 4 minus x squared, will we get the same function? And it's kind of hidden there. Yes, we do. It goes through at -1 and +1, and we have this just touching behavior at 0 because we have a repeated root. Now I did that literally with 12 seconds to go. So that's very, very, very impressive to get to that stage and get there. There is a picture in case you don't have access to GeoGebra. This is what it looks like. Hope you enjoyed this kind of video. If you like it, then let me know in the comments below, where I can do more German maths content, and hopefully this gets you ready for your Schulaufgabe. Okay, bye bye for now.